Okay, I'm just going to give a quick run through of the 20 skills that we've picked out for our questions in class. Most students have not, will only have one lesson skills listed on the advanced information than the 20 skills that are in this selection that we've chosen. But we wanted to give you a chance to go through and see how some of these skills are attacked and successfully achieved. So, question one is just a number problem solving activity. Now, with this one, you could spend a long time guessing and having a go, going to and fro with your calculator. But actually, if you look at it, it ends in a 2, which means it's an even number. So the first thing you could do, and you could get lucky by doing this, is, right, let's take this number. And what if we divide it by 2? Which would have mean that our final answer will be something multiplied by 2. So it is a calculator exam, don't forget that. So I've got it in my calculator already there. 1562 divided by 2 equals 781. Let's just jot that down and then see if it meets our rules, because these are all about meeting the rules. Now, I'm supposed to be using a 7, an 8, 7, a 2, 1, and a multiply. The 7 has been used, the 8 has been used, the 2 has been used on the end there, the 1 has been used, and the multiply, and it equals this number here because that's the number I started with. So I'm going to declare this as my final answer. Now, of course, it didn't work first time. You can look for other options, but you've got to make sure wherever you do, you use all the cards and only the cards that are stated in the question. So a negative calculation. Now, first of all, this one, we've got to look here. We've got something, subtract minus 6. So that is like saying something, okay, take away a minus number is taking away coldness or taking away debt. So if you take coldness away, you actually get warmer. And because those two minus signs are touching there, they actually can turn into an add. Taking away coldness is like getting warmer, so you're going to go up in temperature. Very careful when you use the rules of negative numbers. You can't just apply the negative one on every occasion. You've got to look very carefully where it is. If they're touching together, then yes, you can make it an add. There'll be a PowerPoint coming out with all the different skills on it, and that will go through negative numbers and tricks and rules. Be very, very careful when you add or subtract negative numbers. Anyway, so we've got this now in a better format. If we now move this 6 to the other side, so we're rearranging it, so we're doing the same as both sides, balancing it, then that's gone. We've now got something equals 5, take away 6, we end up at -1. So let's just check that works. You could look here at this stage and say, well, something add 6 is 5, -1 add 6 does equal 5. So this is my final answer. So be very careful when working with negatives. Okay, this one actually trips up a lot of students and it shouldn't do. When they might say to you, express this amount as a fraction of at a different amount. So here I've got a class of 8 girls and 12 boys. What fraction of the class are girls? Express your number in the simplest form. So 8 girls and 12 boys. So straight away, the class in total is 20 students. And we're looking at a fraction of the class are girls. So 8 out of 20 are girls. Remember though, simplest form. Whenever you're looking at fractions, you're always thinking, can I reduce it? Do I need to reduce it? The only time you may not need to do that is if it's a probability and they don't always expect you to reduce your fraction, but otherwise always simplify it. So that can be divided by 2, they're both even. So I get 4 over 10, they're both even still. So let's divide by 2 again, 2 over 5. That is my final answer. It will reduce to no more. I could have gone straight from the 8/20. I could have divided by 4 and divided by 4 and gone straight there. It doesn't matter how many steps you do, as long as you get to the simplest form. Okay, this one is about common multiples. We've got two lights flash 1 p.m. Okay, I think it's supposed to say from 1 p.m. there. So we've got a 1 p.m. start time, and they're going to flash at different intervals at different rates. So light A flashes every 12 minutes. So that would be 12 minutes past. It would be 24 minutes past. It would be 36 minutes past. It would be 48 minutes past. Now you could do a few of these, and it'll be on the hour. Okay, 00. Remember, you're dealing with time here. 1 p.m. start time. Okay, light B goes every 9 minutes. So 9 minutes past, 18 minutes past, 27 minutes past. Add on another 9 is 36 minutes past. We could keep going, but oh, let's look at this. We've actually got a match there. We don't want to end up going too far down the list. So don't go too wild with your lists. Always be mindful and think, have I already got a match? I've seen students in the past have lost a mark because they've gone too far and gone to the next multiple. We're looking at the time when they next flash together. The lights both go off at the same time. So don't forget it's a start time of 1 p.m. So that would be 1:36 p.m. would be the time that the lights next flash together. Okay, multiples is about lists of numbers building up, not to be mistaken with factors. Factors are pulled out of a number. Okay, so multiples are like your multiplication tables going up. And writing these two lists will get you marks anyway for showing you've thought about making lists of multiples. Okay, so question 5. This looks really horrendous, but don't forget you have a calculator. This is all about entering it correctly onto your calculator. You're going to need to make sure you get all of this in your screen looking identical to that. So we're going to start out finding this funny cubed root symbol here. Not often used apart from these sorts of questions here where they're testing your use of the functions of the calculator. Now, if we search here, we can see our cube root is here. It's yellow. We must press Shift to get that bottom. So it's already opened a box for us. Now we've got our cube root sorted. That first one is sorted. Now we're looking at a fraction underneath that root. Let's press the fraction button and we type in 3, 5, 6. Use our cursor to move down. 1, 4, 6. Now be very careful here. If you notice the root sign has stopped. Sometimes those root signs will carry on. If the root sign carries on, then you want your image in your calculator to carry on under the root sign. Here it's stopped. That means you've got to move past the root sign. Okay, so going past the root sign, I've double clicked. I'm now on the next space. So plus, okay, it's looking good so far. 6.2. I need to cube that. Now there sometimes it's a cube button, but here we haven't got a cube button. We've actually got an x squared. We've got an x to the blank. This is the one you want, not on Shift. It's quite a main button. So press X to the blank. It's giving you a box. You now can type in your power. Okay. I'd always go past the end just to be sure. Let's check it's exactly as in the image. All the numbers are correct. The root has stopped as the image has stopped here. Press equals. Okay. So the answer there, I would write down the whole answer on my paper. Just the screen there, 1 second. 67396. I'm going to put a bit more stuff. 67396. 67396. So write a decent amount. If you've got it in front of you, write the whole display down. I just can't see it now. It does say though to 2 decimal places. That means you need 2 numbers after the decimal point. You're going to stop there. It means this next one, the 3rd decimal point, is your decider. That 3 is actually telling us we can round down on the rules of rounding. So your final answer will be 239.6 7. It's not money or anything, it's just a number, so no need to worry about units of measure. So very careful entering on your calculator there. You can always clear the display if you go wrong, of course, and start again. Okay, expanding brackets. Now this one is separated by this subtraction in the middle. You could, of course, get a double bracket expansion where the brackets are glued together, and you might do a grid method to do that. You can still use a grid here if you wanted to, but we've got two separate things to do here. We've got this bracket, 4 times the x, and 4 times that positive 2. We've also got to do, now this is a minus 3. I would deal with the minus 3 right at the start, minus 3 times 3x, and minus 3 times positive 5. Whatever's in this bracket really matters. If that had been a negative, a subtract, you must do times a negative 5. So watch out for the signs really carefully. So this first set, 4 times x is 4x, 4 times 2 is 8. Okay, the second lot, minus 3 times 3x is minus 9x. Minus 3 times 5 is minus 15. So now we can use our sort of circle and box method if that's what you use. We've got 4x, take away 9x. And then we've got positive 8. So we're dealing with the different terms here. It's just a constant and the others are the x. You could have a c or a b or a y or anything else in there. You put them together. You could have a squared. A squared term would be collected up separately too. So we've got 4x, take away 9x is going to leave us with minus 5x. Always think about using a number line if you're not sure with negatives. Positive 8, take away 15. Of course, we've got our calculator. We could do that if we wanted to. And I will use that just now to show you where a negative sign is. We've got 8, take away 15. So 8 minus 15. Okay, we've got minus 7. Okay, so we've got our final answer there. So don't forget you've got your calculator. Be very careful though, if it had been minus minus, to put in a minus minus. So on your calculator, you've got this little button here that can be used as a negative sign. You can also use the subtraction as a negative sign. Okay. So that's our final answer. Just something to show you actually on here. You could do minus 9x, and that's a positive 4x. Okay. That is exactly the same as doing 4x minus 9x. You've just rearranged the order, but you've kept the sign with the 9x. You've kept the positive with the 4. Minus 9 plus 4 is minus 5. Same thing. You might find it easier to do that, but be very, very careful. Keep the signs together. And likewise, minus 15. I've kept that sign plus 8. You might be happier doing that, especially on a number line. Okay, but you've got a calculator, so it shouldn't be a problem here, but just something to think about. So that is the final answer. Okay, factorizing. So that means putting back into brackets. Now, because this has got 2 terms, okay, I know it's highly likely to be one bracket. There is one that could look like this, that's got 2 terms, x squared minus 36. That's got a squared and just a constant and a minus. That is something special, and it would come out as x plus 6 and x minus 6. That's a special case. You've got a squared x or squared y, a minus, and a square number. It's called the difference of 2 squares, and that is a separate case. So those are the only ones with 2 terms that have a double bracket. Otherwise, our 2 terms here are 20a, 25a squared. They don't fit that pattern. So we know it's going to be one bracket. So we're looking at what can we take out of this first term and also take out of this second term. So we could actually rewrite this first one as 25, okay, a because it's a squared or a times a. So if you look at it now, you can see you've got an a in both of them. We could take out an a or take off a power of a. There's two powers of a here, one power of a here. We could take off an a. So that a is going to come on the outside of our bracket. We are pulling that out as a factor. What does 20 and 25 got in common? Well, they both divide by 5. So if we divide by 5, we can pull that 5 out. Okay, so we're dividing both sides by 5. And we have actually divided both sides by a. We've pulled out things they've got in common. So what's left then? If we do 20a, divide by 5 and divide by a, the a's gone because we've pulled it out because we've divided by a. 20 divided by 5, we are left with 4 minus 25 divided by 5 is 5. A squared divided by a, we're taking one of the a's off. We're left with an a. Now, you can actually check this and know you've got full marks. If you were to multiply this back out again, this is like a little check. You could always do a check and make sure you put your final answer on the answer line. So a check is 5a times 4 is 20a. 5a minus 5a, 25a squared. Yes, you've got back to where you started. So we know this is correct. So we'll declare that as our final answer, 5a 4 minus 5a. We've checked it works. We know it works. There's nothing else in common left in that bracket, just a final check. Okay, so find the value of y when x is 5. This is just a substitution one. You've been doing some with coordinates in a previous set of 20 questions for paper 2. When you're given an equation like this, if you're given a set of coordinates to do instead, then the x and y coordinates are in the bracket. You can substitute the x and substitute the y in, or it might be the x is missing or the y is missing. You put one in, out falls the other coordinate. So this is even easier than those. We're going to put that x equals 5 into this. So we've got y equals 5 squared plus x. Okay, so we've got 25, and actually I can replace that x there then, can't I, as well? 25 plus 5, because this is also an x, so it's 5. So y equals final answer. Okay, just put in the number you've been given into the equation.